Welcome back. This is the continuation of previous video in which we started talking about monopoly. In this video, we will look at a general setting. What is a general setting? That there is a monopolist, only one seller in the market, and there are many potential buyers. And this seller faces a downward sloping curve, which can be given as Q as a function of P, or we can also say that P is a function of Q. Of course, this is a demand function, this is inverse demand function. Both are, because if there is one-to-one correspondence, there is no problem which one you use. And so monopolist problem is that maximize with respect to Q, P multiplied by Q, this is the total revenue, minus C of Q. So what we are assuming, let us be clear that the monopolist is operating in the output market. Of course, monopolist also has to buy raw material, and it has to use raw material to produce final product. We can say the monopolist is price taker in the input market. Remember, we had done cost minimization and we had figured out that cost would depend on input prices, and we said because it doesn't control, it takes, because it is price taker in the input market, we can say this is simply C of Q, and that's what we have written here. And once we do maximization here, of course, unlike perfectly competitive market, P is not given from outside. P is a function of Q, or Q is a function of P. You know, if you decide if you are the monopolist and you decide how much is the P, Q will automatically get decided, or you decide how much is the Q, P will get automatically decided. They are linked to one another through market demand function. So if we, first order condition would be you differentiate it with respect to Q. And by the way, this is not new. When we were talking about price elasticity of demand, to get the cutoff for the elasticity, this is what exactly we had done, and we are going to repeat it once again. That would be revision for you. If you differentiate P with respect to Q, you will get dP by dQ and Q, and then you will have just P. As you differentiate Q with respect to Q, you will get 1, and this you will get MC of Q. This is the total cost, this is the marginal cost. This is what you are left with. This can be rewritten. You can take P out, you will get 1 here, and this is going to be Q by P dP by dQ minus MC of Q. This we had obtained. If you remember, this is nothing but negative of inverse of price elasticity of demand. So I will jump ahead. You can go back and look at that elasticity video. This can be written as, I will also give you, this is nothing but dQ by dP multiplied by P by Q minus. If you remove the minus sign and take the inverse, this is what you get here, and that's why this is what it is equal to MC. I can also keep on writing here that MC is a function of Q if MC is changing. Further, I can write that 1 minus 1 by epsilon is nothing but MC by P. And further, 1 by epsilon is nothing but P minus MC by P. What are we getting here? This is the criteria for profit maximization for the monopolist. This is price elasticity of demand. So this is coming from the demand side. Remember, I should remind you that on perfectly competitive market, let me write it here, for in short perfectly competitive market, PCM, what do we have? P is equal to MR is equal to MC. That was the optimization criteria for profit maximization. So basically P is equal to MC. Here P can be greater than MC if epsilon is not equal to infinity. Because think about it, if epsilon is, you know, equal to infinity here, if one, we can calculate for some values. Let us look at epsilon can vary between 0 to infinity, that's what we know. Let us take example, epsilon is equal to infinity, 1 by epsilon is going to be equal to 0. By the way, epsilon will never be equal to infinity, it will tend to infinity. I am abusing the notation, but I am an economist, I have that freedom. Jokes aside, as long as it is clear what we are doing, there is no harm in taking these shortcuts. So, and in that case, P is going to be MC. What does it mean? That if monopolist is facing a horizontal demand, that is perfectly elastic demand, then it cannot set price higher than the marginal cost. It's going to be P is equal to MC. But if epsilon is any other number, there is another possibility. Let us say if epsilon is between 1 to infinity, what is going to happen? 1 minus epsilon is going to be between 0 and 1, and it means 1 minus 1 by epsilon is going to be greater than 0, or it's going to be between 1 and 0. In that case, P is going to be greater than MC. What it means, what does it mean is that monopolist can have a markup over the marginal cost. And this markup is, typically it's in our day-to-day thinking also. We expect that how much of markup is justified. Of course, in economics, it depends on price elasticity of demand, but in our mind, we also have a number. We say, a too high markup is never a good idea. But it all depends that how much is the price elasticity of demand, or how much is the inverse of price elasticity of demand. If it is very, very elastic, even if monopolist would like to have a very high price, but it cannot ask for a high price, it has to go with the MC, near to MC. But if price elasticity is much lower, then it gives monopolist a lot more freedom to charge a higher price. Now that's what we understand. Now let us see, what if epsilon is between 0 and 1? It means demand is inelastic. We don't need to worry about it, as a monopolist would never operate in inelastic zone. Let us understand what happens. Profit is PQ, or here it is TR minus TC. That's what it is. And TC is basically, we can say it is a function of C of Q, and let us write TC below. Okay. Now, if demand is inelastic, meaning the demand is in this zone, what will happen? You increase P, total revenue will increase. Isn't it? That's what we have discussed when we talked about price elasticity of demand. If demand is inelastic, as P goes up, total revenue goes up. As P comes down, total revenue comes down. So if you have difficulty in understanding this, I would say go back to the video that we had on elasticity. It would help you understand. So P goes up, total revenue goes up. But not only as P goes up, Q comes down. As a result, total revenue is going up for inelastic demand, not always, but for inelastic demand. And as P is going up, Q is coming down, C of Q will come down all the time. So let us look at profit. What is happening? PQ minus C of Q. This whole thing, as P is going up, let's say for epsilon between 0 and 1, as P is going up, PQ is going up. It's inelastic, therefore 1% change in P is not bringing big enough change in Q, and therefore as P is going up, PQ is going up, and C of Q is coming down. Why? Because as P is going up, it implies Q comes down, and therefore C of Q comes down. So this part is going up and the negative part is coming down. So as a result, profit will go up. So if the monopolist is operating in inelastic zone P going up means profit going up. So a monopolist can never maximize, will never reach to the point where it is maximizing the profit if it is in inelastic zone. Therefore, we don't need to worry about this part. Optimization is always going to happen in this particular zone, which means that it is elastic zone. So that should be clear to us, and therefore there would be a markup price. But now let us understand that what kind of problem the monopolist is facing, that we already saw that MR is equal to P1 plus, let us, we can see, we can write this entity, or we can write in this form itself, that P plus dP by dQ multiplied by Q. That's what MR is. And how are we getting MR as this? What is MR? The rough idea about MR is that if Q goes up by 1 unit, how much change we get in total revenue. That's what MR is. So if Q is going up by 1 unit, the thing is that P will come down, and P will come down not only for the last unit but for all units bought or sold in the market. So if you want to increase Q, you have to bring down P. So if Q goes up by 1 unit at that price, how much would be the additional revenue? That's going to be equal to P, as we had in perfectly competitive market setting. But here we have slightly different result. Because of Q has gone up, P has come down. So now from each item, let us say P has come down by delta P, from each of the units you will get delta P less. So of course Q is going up, delta P is negative. So this is what you will get, delta P multiplied by Q less. Or we can say, because instead of saying, because we are talking about delta P, instead of saying Q going up by 1 unit, we can say Q is going up by delta Q unit. So P has gone up by delta Q unit. This is increase in the revenue because of the more item bought, and this is a decrease in revenue because for each item prices have come down, and this should be divided by delta Q. You will get P plus delta P divided by delta Q multiplied by Q, and as delta Q goes to 0, it will become P plus dP by dQ multiplied by Q. And exactly this is what we get here. This is exactly what we get here. Okay, if you want me, I can go into a little bit more detail. Let us say that earlier price is P, quantity is Q. Now price is P plus delta P and Q is Q plus delta Q. Of course, if delta Q is plus VE, delta P is going to be minus VE, or other way around. So how much is the change in the marginal revenue? We can say how much is the marginal revenue? That would be the change in revenue, which is P plus delta P multiplied by Q plus delta Q minus PQ, and because we are looking at the change is coming because of delta Q, so we have to divide it by delta Q. We will get 4 terms here, PQ plus delta P multiplied by Q plus P multiplied by delta Q plus delta P delta Q minus PQ divided by delta Q, and this will get cancelled. And so from here we will get first term and denominator we will get Q delta P by delta Q, exactly like this term. From the second term we will get P, delta Q and delta Q will get cancelled, and from third term we will get delta P. But this is an additional term that we were not getting earlier. What's happening to this? We can say now take limit delta Q goes to 0. As delta Q goes to 0, delta P will also go to 0. So what you are left with is, we can write here Q dP by dQ plus P, and this will become equal to 0. So this is the term that you get. Graphically speaking, this we have already discussed. So graphically speaking, we can say that here is the, let us say here is Q, here is P. If you move here, this is additional revenue that you are getting from Q to Q plus delta Q, and this is the delta. Here earlier you had P and this is P plus delta P. So this is what you are getting. We can say the area is going to be equal to P plus delta P multiplied by Q plus delta Q minus Q. This will get cancelled. So P delta Q plus delta P delta Q, and this will go to 0, very small. So you are getting P delta Q because you are buying additional item. But each item, this is what you are losing. Earlier you had this whole area, but now you have a smaller area which is this. So if I said it, this is what you are losing. And how much it is equal to? It is equal to, simply it is P plus P. We can say P minus P plus delta P, and sign can be problematic, but that's okay. Delta P multiplied by Q. So this is what Q delta P, that's what will be the loss in the revenue because of that. That's what you should understand. Okay. And so this part should be clear to you, that what's happening in the general setting. So before we move to welfare loss, I must remind you once again what we have obtained as optimization condition is P minus MC divided by P is equal to 1 by epsilon, and we have also figured out that a monopolist will operate in a zone where epsilon is between 1 and infinity. Okay. And this particular P minus MC divided by P, this is what we call markup over marginal cost. You should also understand that this formulation is also acceptable. This formulation is also acceptable for perfectly competitive market, because there we get, according to this formulation, P is equal to MC, because demand is perfectly elastic. This is called Lerner's index. Lerner's was an economist. This particular is called Lerner's index, and it measures the market power. What do we mean by market power? Ability to set price above its marginal cost. So we can say, in a firm operating in the perfectly competitive market has absolutely no market power, because price he has to be set equal to marginal cost. Monopolist has the market power, and that market power the firm is deriving because the demand curve is downward sloping. It has some price elasticity of demand. Good. So let us move to welfare loss. Before we talk about welfare loss, we have assumed one thing, that the monopolist charges the same price to everyone. Monopolist cannot do price discrimination, at least in this setting. For two reasons, monopolist cannot do price discrimination, as we are assuming here. That one, the legal reason, you cannot sell the same item to different people at different prices. And second is arbitrage. Let us say that there are only two buyers, Mohan and Sohan, and the monopolist decides to sell Mohan at 20 and Sohan at 40. What will stop Mohan to make a deal with Sohan that you don't purchase anything from the monopolist, I will sell you this product at a price lower than 40. Sohan of course would be happier, but it means monopolist would be selling everything to Mohan at price 20. Automatically you reach to one price only system. But later on, when we talk about price discrimination, there are some nifty ways that firms can use to do price discrimination. We will discuss them. But so far we are assuming that there is only one pricing. And let us say we draw, let us look at it graphically. We draw a downward sloping demand curve. It's not necessary that we have the linear demand, but it's just convenient. So I'm drawing the linear demand, that's downward sloping linear demand. We can say it is demand function. This is marginal revenue, and then let us say this is marginal cost curve. This is demand, this is marginal revenue, and this is marginal cost. Let us also graphically obtain the equilibrium. At this point, at this Q star, MR is equal to MC. So wherever MR is equal to MC will give us condition to obtain Q star, and this is the Q star. But price is not being determined. Remember that P is no longer equal to MR. P happens to be greater than MC, and therefore P is also greater than MR. How to obtain P graphically? Let us look at it. What is the relationship between P and Q, and from where we are getting? The relationship is coming from the demand function. Where is the demand function? This is the demand function. So if Q star is the amount bought in the market or sold in the market, how much buyers are willing to pay? So this Q star, we will find the corresponding P star from the demand function. So this is going to be P star, or we can say it is P monopolist and this is P monopolist. Okay. Also understand this demand function. We can also say this is, what is demand function? We are writing, how are we writing the demand function? P as a function of Q. So let us also look at the average revenue curve. Average revenue curve is going to be equal to total revenue. So P multiplied by Q divided by Q. So this is also not only the demand function, this is also the average revenue curve. Okay. So by now you understand this is QM star, this is PM star. Let us try to understand that if there were identical firms in the market, everyone had the same MC, how many units would be bought and sold in the market? Let us look at it, because here is Q star C, because how do we get? MC upward sloping curve gives us the supply function. Here, that would be the supply function, and this is the demand function. So this is the, we can say P star C is going to be perfectly competitive equilibrium. So now we have clarity that if we name these points for convenience, let us say this is A, this is, or we can say, we can name different areas. This area is, let us say A, this area is, let us say B, this area is, let us say, this area is, let us say, C, this is D, and this is E. So we can say in perfectly competitive market, how much is the consumer surplus? It's going to be A plus B plus C. Let us say perfectly competitive market. And producer surplus is going to be, sorry, A, B plus D. This part, and D. And how much is the producer surplus? C plus E. And how much is the total surplus? A plus B plus C plus D plus E. Now let us look at the monopolist. How much is the consumer surplus? Now only these many items are being bought at PM price. So this is going to be consumer surplus. So this is equal to A. How much is going to be producer surplus? Producer surplus is going to be B, which is this part, C, which is this part. B plus C. And so total surplus is going to be A plus B plus C, and deadweight loss is going to be D plus E, because this is not. By the way, I have made a mistake, a small mistake I would correct. C was not a smaller box even in the earlier case. The whole thing, let me use a different color. See, this whole thing was C even for the first part. This is C, because this is the way marginal cost curve is. So you should correct, the previous description was bit wrong, but I corrected it. Okay, and so this much is the deadweight loss. So society as a whole loses something. Notice that you have bundles here. This much is the cost, let us say this much is the cost, this height is the cost, and there is a consumer who is willing to pay more, but monopolist is not interested in selling to him. Why? Because to sell to him, monopolist will have to decrease price for everyone, and that decrease is not beneficial, profitable for the monopolist, and therefore monopolist would deliberately forego selling to those people whose demand is in this particular zone. Okay, so deliberately restricts itself, and that's why we are having a welfare loss in such a system.